Welcome to you all in my YouTube channel Express Mathematics. In today's video, I am going to teach you how to plot the graph of the curve having asymptote. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make similar type of videos, and also press bell icon so that you will be informed about my coming videos. So now let's start today's topic. Here we have to draw the graph of y equals to 1 over x. So here, first of all, look at the solution of this. We will check where the graph intersects x-axis or y-axis. For that, we will put y equals to 0 and x equals to 0. Here, putting x equals to 0 in above equation, y will be 1 over x equals to 0. So that means this implies y equals to 1 over 0 means infinitive. So when one variable value is infinitive, this x equals to 0, this gives us asymptote. Therefore, x equals to 0 is the asymptote to the given curve. Okay, that means the curve goes together with x equals to 0. X equals to 0 means actually it is y-axis. Okay, and it doesn't meet y-axis at the finite distance, but it meets y-axis at infinity. Okay, so this is one of its characteristics. Similarly, next characteristic is from given equation we have, okay, here you can write x equals to 1 over y, and when y equals to 0, x equals to 1 over 0, this implies x equals to infinitive. So when one variable value is infinitive and at the time other variables equals to finite value, this equation gives us asymptote. So this y equal to 0 means actually it is x-axis. So by the definition of the asymptote, so y equals to 0 is asymptote to the given curve. Okay, this is asymptote to the given curve. That means it doesn't meet x-axis at finite distance, but it meets x-axis only at infinity. Okay, so we have found out that what are the asymptotes to the given curve, and next to that, so this the curve is not defined for x equals to 0, so the domain equals to set of real number minus 0. Similarly, it is not defined, or x is not real value for y equals to 0, so range equals to also set of real number minus 0. Okay, so these are the characteristics of the given curve. And also when x equals to minus infinity at the time y equals to 0, and when y equals to minus infinity, x equals to 0. So the curve will be in the opposite quadrant. Curve will be like this. Origin x-axis y-axis. Here x-axis, equation of x-axis is y equals to 0. Y equals to 0 is also asymptote, and equation of y-axis is x equals to 0. Both of these are asymptotes, and when x equals to y equals to 0, at the time x equals to infinity. X equals to infinity means it is at very far end here. So the curve will like this, okay. And when x equals to 0, at the time y equals to infinity. Y equals to infinity means at the very far end of y-axis here. Similarly, when x equals to minus infinity means at the very far end here, at the time y equals to 0, y equals to x-axis. So the curve will also be in this position here, okay. X is minus infinity, but at the time y equals to 0, y equals to 0 means x-axis. When y equals to minus infinity means down here, very far end, at the time x equals to 0 means y-axis. So the curve will be in the opposite quadrant, okay. Or in other words, it is the odd function. So odd function is symmetric about the origin, okay. So the curve of this will be of this nature. So I have shown the graph of this curve with different characteristics. This 1, 2, 3 number, these are the different characteristics of the curve. And now let's look at next curve, y equals to x plus 2, okay. So here look at the solution to this. When x equals to minus 2, y equals to 1 over minus 2 plus 2, this implies y equals to 1 over 0, this implies y equals to infinity. That is y equals to infinity at the time x equals to this binary value minus 2. So x equals to minus 2 gives us asymptote. So this is asymptote, okay. X equals to minus 2 is the asymptote to the given curve. So x equals to minus 2 is asymptote to the given curve, okay. And also we have what we can write is x plus 2 equals to 1 over y we can write, and this implies x equals to 1 over y minus 2. So when y equals to 0, x will be y equals to 0, then at the time x will be infinity, okay. So infinity minus 2 is also infinity. Therefore y equals to 0 is, this is asymptote, okay. Therefore, so y equals to 0 is also asymptote to the given curve, okay. So this asymptote means actually it is the straight line. The curve goes together with the straight line, but it doesn't meet this straight line in finite distance. It meets only at infinity. And next, that third characteristic is here y is real number for all real values of x except -2. Therefore your domain equals to set of real number minus -2, and your x is real for all real values of y except 0. So range will be set of real number minus 0. Okay, so using these characteristics we can plot the graph of this function. Okay, origin x-axis, y-axis, here x dash, sorry, y dash, here x dash. And now this is 1, 2, here -1, -2, -3, -4, and so on, here 3, 4, and so on. Okay, so x equals to -2 is the asymptote, so x equals to -2 is the straight line parallel to y-axis. So this is the straight line, x equals to -2 is the straight line parallel to y-axis, and this is the asymptote to the given curve. When y equals to infinity means at the very far end of y-axis, infinity is in this side, at the time x equals to -2. So the curve goes together with x equals to -2 in this direction. And also y equal to 0. Y equals to 0 means it is x-axis. Y equals to 0 is the x-axis. So the curve goes together with x-axis also, together with x equals to -2 also. So the curve will be like this. So like this type of curve you will get. And similarly, when x equals to -infinity at the time also, y will be 0. X equals to -infinity means at the very far end of the left hand side, at the time also y equals to 0. So the curve will go in this direction also. And when y equals to -infinity at the time also, x will be nearer to -2. Okay, so y equals to -3, x will be -2. So curve will -3, y value -3 means at the very far end on the negative of y-axis. So the curve will be in this direction also, go together with this y x equals to -2 in this direction. So the curve will be of this type. Okay, and next to that, this same curve can also be obtained with the help of this curve in question number 1, because we know that the curve fx plus a, y equals to fx plus a, is the translation of y equals to fx by a in its left. Okay, so here previously I have shown the graph of y equals to, this is graph of y equals to 1 over x, and this is graph of y equals to 1 over x plus 2. Okay, so this is the translation of this graph of this y equal to 1 over x to the 2-step left. Okay, so if you translate this graph 2-step left, then also we can get the graph of, if you translate the graph of this first one 2-step left, this one if you translate 2-step left, then you will get the graph of this next curve. Okay, so as we have already discussed in translation of the graph, the graph of the graph of y equals to f(x plus a bigger than 0 is the graph of y equals to fx translated by a units to the left. Okay, so here fx equals to y equals to, we have 1 over x, and f(x plus 2 will be equals to 1 over x plus 2. So the graph of y equals to fx plus 2 equals to 1 over x plus 2 is the translation of the graph of the graph of y equals to fx plus a bigger than 0 is the graph of y equals to fx translated by a units to the left. Here fx equals to y equals to 1 over x, and y equals to fx plus 2 equals to 1 over x plus 2. So the graph of this y equals to 1 over x plus 2 is the graph of y equal to 1 over x translated by 2 units to the left. Okay, so by translation to the 2 units left, you will get the graph of this type of function. So here while translating, it will be convenient to translate the straight line, because translation of this curve will be difficult. So here x equal to 0 is the asymptote here. So this asymptote, if we shift 2 steps left, then it is x equals to 0 here, and while shifting 2 steps left, it will be x equals to minus 2. So x equals to minus 2 is the asymptote, and taking this x equals to minus 2 asymptote, we can draw the curve nearer to x equals to minus 2, and this same curve in opposite quadrant we can draw, and in this way we can get the curve having asymptote. So either by translation or by finding out the asymptote, we can sketch the curve having asymptote. Okay, the main thing you have to know while sketching curve is only the infinite curve has asymptote. Every curve doesn't have asymptote, so we need not search the asymptote to the every curve. Okay, so if the curve has asymptotes, then using asymptote it is quite convenient to plot the graph of the curve using asymptote. I hope that you found this video helpful. Thank you for watching, and if you have not already subscribed my channel, please subscribe it right now, so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. Thank you.